reactants we need. All right, so this is, again, stoichiometry, if you want to write that in there. This all falls under that category. Okay, so let's just start out with an example problem. So let's say, example 1, we want to make 40 moles of potassium oxide. K2O. How many moles? Is this marker okay, or should I toss it?
That's good. No, that's fine.
Okay. How many moles of potassium? That's K. And of oxygen, that's O2, do we need? So the first thing we need is the actual reaction, so I'll write that up for you. So it's K plus O2, you might have guessed that, yields K2O. Okay. And then before we can figure out how many moles of each one we need, we have to balance the equation. Otherwise, we're wasting our time. I'll just balance this one for you. This is going to be a 2. This is going to be 4. So remember, everything we're going to do over the next few days, you're going to have to balance every time. All right, so now we have that. So now what I'm going to do is I'm going to take what's given, 40 moles of potassium oxide, and I'm going to use that to find the other two. So we'll do each one separately. So 40 moles K2O. And I'm going to do this like we did conversions. You're going to put parentheses in front of here. And whatever's out here, you're going to put on the bottom, the chemical. So K2O. And then whatever you're trying to find, you're going to put on top. So let's do potassium first. So we'll put K on top. And then what you need to write in here is the mole ratio that has potassium over potassium oxide. So that's the whole reason we did all that stuff on Friday, is so we know what numbers to put in here. So what's going to go on top? 4 moles. What's going to go on the bottom? 2 moles. So we're just doing these numbers here, right? So all we have to do here is 40 times 4 over 2, which is really just 40 times 2. And this is going to cancel out, so our answer will come out in moles of potassium. So it'll be 80 moles of K, potassium. Questions?
Why do you do that with 4 moles?
This?
Yeah.
40 times 4 is 160, divided by 2 is 80.
Oh,
Okay? Right? Always remember, when you multiply a number times a fraction, always, 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 you're multiplying times the top and dividing by the bottom. It never changes. In here in math class, always multiply times the top, divide by the bottom.
Well, you're supposed to do the parentheses first.
Well, you can do the parentheses first. 4 over 2 is 2, right? 40 times 2 is still 80. So it actually doesn't matter either way. All right, we got to do the other one. We got to figure out oxygen, right? So it's going to be 40 moles, again, of K2O. Start out with what we have. Same thing, K2O in the bottom. Just this time we're going to put oxygen on top, O2. And so we're going to put 1 mole of O2, because there's no number here, so that's a 1. And we're going to put 2 moles of K2O. So here it's 40 times 1 over 2, so it's just 40 divided by 2. That's going to be 20.
Wait, isn't that 3 oxygens though?
1 mole of O2. So it's 2 moles of individual oxygen atoms. So we care about how many moles of O2 molecules. So it's just 1. So 40 divided by 2 is 20 moles of O2. I think this goes away. Did I actually answer your question? Did I answer your question?
Yeah.
Okay. All right. So what this is saying is if we want to make 40 moles of potassium oxide, we need These are our ingredients. This is stuff we got to add, mix together to get that. If we use more of one of them, we get wasted. If we use more of both of them, we make more stuff. Questions? Should I do another one?
That's it.
All right, that's it. All right, let's do one more. Should I write it here or should I erase?
Right there.
Can I?
You can erase.
Is everybody caught up? Can I erase?
Yeah.
Anybody not caught up?
If they're not, it's on
All right, I'll erase the top this way. We'll do a little bit of time. All right, so do how many moles of aluminum and sulfur? Sulfur is S8. That's how we usually get it. Are needed to make 300 moles of aluminum sulfide, which is Al2S3. Okay, so first thing we have to do is write out the equation. It's going to be this and this. We're going to make that. So aluminum plus sulfur, that's an 8, right? Makes Al2S3. Okay, so we got to balance this. It's going to be an 8 here, a 3 here, and a 16 here. Okay? So again, we're just going to do the same thing. We're going to write 300 moles of this stuff. 300 moles. What? What's the question? What's up?
What's the numbers?
This number? This came from here. It's in the question. How many moles of stuff do we need to make 300 moles of Al2S3? So I'm just putting what I'm given. And then again, parentheses. Whatever's out here, that's the same compound that goes in the bottom. Al2S3. Whatever we're looking for, so we'll do aluminum first, goes on top. And then we're just going to use whatever numbers in our balanced equation. So this is an 8 moles. This is 16 moles. So 16 over 8 is 2 again. So that's kind of easy. 300 times 2. 600 moles of aluminum. Am I going too fast or are you okay? All right. And then we're going to find sulfur. So again, 300 moles of Al2S3. So same thing on the bottom. And then sulfur goes on top. Let's see. So it'll be 8 moles on the bottom, 3 moles on top. This number, right? Okay. And so now it's 3/8 times 300. Set them out here. Moles of S8 sulfur. So there's our two answers. We need 600 moles of aluminum and 112 moles of sulfur. That's it. Questions? So that's when I balanced it. Yeah, so remember in all these mole ratios, it's always the numbers from the balanced equation. Only on the outside here will you have this number that I give you in the problem. Anything else? All right.